All right, just one thing quickly as we get started here I wanted to show you, and that is I've got this. This is actually something he's got at the bottom of his stuff, but this is select location. So in other words, it'll show all the locations. This will say count, so give me a count of how, so you can see here, it's kind of hard to see, but it says Massachusetts 3, New York 2, Rhode Island 1, Wentzville 1. Okay? And if I want to, because by default, if I run this, it calls this literally count. This is the name it gives it. So if I want to rename it, I can say as, and I can say, for example, location count, which looks a little nicer if I run it, or L count or something else. All right. Okay. So the next thing that he does in here then is he adds another table. Now you'll notice if you look at this, it's a new table called posts. You can already see it's got an ID in it. Again, an int and an auto increment, a user ID. This field right here, this field is the ID field from the users table. Does that make sense to everybody? All right. Also, this field is text. Text has, whereas varchar has a max of 255, text has a max of 65,536. All right. This is another way. Typically, almost every kind of programming language supports a timestamp. So a lot of times, rather than date, you'll see that rather than now, you'll see current timestamp. All right. So this is going to be a post table, and as you can see, as far as what's in here, we've got about 6 or 7 fields, and most of them are ones that we've already seen. You've seen all this before. I just mentioned text to you. I mentioned the timestamp. Here we're setting the primary key, so that ID is this one right there. But we're saying, hey, we want to be able to reference the user ID from the users table. In the users table, it's called ID. In our table, it's called users ID, or user ID, I should say. So if we put this in, and run it, and again, if I come in here now and type in now select, not even select, show tables, and I run it, you'll see now there's 2 tables. There's posts and there's users. All right. Well, he keeps this really simple in his example. He adds data, so he puts in about 10 posts that just are all numbered, but they'll say like post 1, post 2, post 3, etc. But the key takeaway here is that's for user 1, that's for user 3, that's for user 1, that's for user 5, etc. So I'm going to grab this, and I'm going to copy it to the clipboard and put it in here and run it. And now you'll see that after we do that, if I select star from posts, and I run it, now I've got these in here. All right. Like I said, I wish there was a way to make this bigger, but I don't know how. I tried doing a few things and nothing seemed to work. All right. So different kinds of joins. We're going to look at all of them, even though they're not all shown in here. All right. So the first one is an inner join. It's the one that's used most often. So this is saying from the users table, I want first name and last name. From the post table, I want title and publish date. All right. And the field that you are going to be joining on is user ID and post user ID. All right. So from the users table, the ID field, and from the post table, the user ID field. Only when they match, give me these. All right. And after this, I'm going to run something that's not shown in here. There it is. Let me move this down so you can see the whole query. All right. So when we run this, what do we get? Well, as you can see, first name from the users table, last name from the users table, post title from the post table, and the post publish date again from the post table. Now, I believe I did not try this, but I don't know why what I'm about to show you wouldn't work. All right, so I'm going to do this. I'm going to say P, and P. Now to do that, I've got to come over here and say users U to posts P, because I'm aliasing right there. All right. When I put the entire table name in there, that's typically what's referred to as a fully qualified query. Some people like to do it like that. I know developers who will put it, even if it's just one table, they'll never use aliases. They'll always do it like this, but this should work. And you can see I got my same data back. All right, just makes it a little easier, that's all. Now, if I do this, and I say left join, that says show me everything on the left-hand side. All right, so show me everything from the table on the left, regardless of whether or not there's a match on the right. So if I run this, in this case, it'll work fine because that was the users table. But notice if I make it a right and I run it, well, I thought that it would show me, usually it'll show you some nulls on one or the other when you use a left or a right join. All right. The one that we're going to use almost exclusively is going to be inner join. You may or may not remember to, but the other way that you can do this is I can come in here and say, this is the way I was taught it, post P, and you have to say where, like that. I think that's a better syntax, all right, and it should still work just fine, and it does, all right. But the recommendation is today to do it this way instead of the way that I showed you. All right, I'm not sure why. Supposedly it runs faster internally because that was created for this. I don't know. All right, now notice we're going to create another table called comments, and with that table, notice it has 2 foreign keys. So in other words, we want to be able to join all 3 of the tables together. All right, I think that might be where he's going to show, yeah, that's where he's going to show the joins, and you'll see some of them. All right, so I'm going to grab this and put that in here and run it, and I should now have a new table. I can always again tell by show tables, and there should now be users, posts, and comments. There they are in alphabetic order. This is adding the actual data or the comments themselves in. So again, I can now say select star from comments if I want. If I want to actually see those comments, there they are. All right, and you'll notice when you look at this, what is this? Well, these are the IDs. Those are just the specific numbers for these. This says it was post number 1 that was made by user number 3. Post number 2, which was made by user number 1, etc. All right. So I guess I jumped a little bit ahead of myself because now he's going to show you the left join, and one of these should return some nulls. Either the left or the right, or maybe even both. I don't remember. Well, that one didn't. Let's see if right does. See that? So in other words, what this means is there were no comments on these posts yet. All right, does that make sense? And it's on the second one, so we have posts and we have comments. All right, since it's a right join, it says show me every comment. All right, and even though there aren't comments on some of them. Sometimes an inner join is also referred to, and I don't know if they'll let you do it like this, but it used to be you could call this an equijoin, like that. I guess they don't like that anymore, but that's what it is. All right, here they're joining multiple tables. All right, so you've got two inner join statements, nothing new there. We've looked at these already. The only one we didn't look at was this one. I don't think we even have to run this because it'll put something in uppercase or lowercase. All right. And again, this is the group by. So this says, give me the ages and a count of how many people are that age from users group by age. So if I ran this first one here, everybody's got a different age in here as far as I remember. So the counts are probably all going to be 1, and they are. All right. But with the next one that's in here, this says where age is over 20, and then group it by age. All right. And the last one is kind of what I showed you. Now, you can have, just so you know, you can have a where, then a group by, and then a having. When you do the where, it runs this before it does the group by. If you put a having in, it does the having after the group by. That's why they have to be in that order. All right. All right. I'm going to shift gears a little bit. I sent you another email today. Some of you, I can see, were already looking at it. And where is it? There's 2 documents I gave you. One's got only 2 pages. The other one has got about 19 pages. All right. And I went and got these from a website. All right. For whatever reason, I don't know if he's enthralled by it. I have no idea. But that umlet, all right, that's the one that Mr. Smith wants people to use, which is fine. Lucid Chart also is you can use it for free for a while. Then they want to start charging you, but that would have worked for us as well. The Lucid Chart site had a lot of really good documentation. All right. So why am I showing you this? Because I'm about to give you your homework, your next homework. All right. And then we're going to do something. And some of you who I know like working by yourselves aren't probably going to like this because I am going to ask you to work in groups of 2. And on these very professional looking pieces of paper that I have in my pocket here, I have either a 1 or a 2 on them. There are 2 1s and there are 2 2s. And you get to each pick one. All right. And, so if you both get 1, you're together. And then you 2 would both have 2 and you're together. All right. I tried to make it what I hope would be as simple as possible and as fair as possible. So you're going to be doing this in just a couple minutes. We'll go over the whole homework in just a second. I'm going to hand it out and I'm going to put it up on the screen here as well. But when you are given requirements, the first thing you want to do is, as it says, determine the entities. You'll notice if you look in here that virtually all of these entities are nouns. All right. So if we were doing, like it says in this example, so if we were doing something for school, student, course, professor, there might be other things in there too. All right, but these are entities. So that's the first thing you want to do is you want to figure out what your entities are. Next, you want to identify the relationships between entities. All right, what you don't want to have is you don't want an entity that's an island. In other words, you don't want to set up an entity that's not hooked up to any other entity. All right? And if that's the case, then you probably want to go in, if you remember from yesterday, we talked about those jump tables and stuff. You might want to do something like that. So step one, you identify the entities. Step two, you identify the relationships. As it says, they show how entities interact with one another. They are typically verbs. All right. Then in step three, you add the attributes. So for instance, student, course, and professor. Well, we're assuming each student has an ID, and I probably wouldn't have made it name like that. I would have probably made it first name and last name. All right. And if middle initial or middle name is important, I'd list all three. All right. Now, in here under the course, I'd probably have the course ID and and probably the course name, something like that. And for the faculty, yeah, maybe an ID, and again, probably first name and last name. All right. Then, as it says, you set the ERD, the entity relationship diagram, up to show all this. So why am I showing you that? Well, let's go to the other one. And I will tell you, I'm not asking for kudos or anything like this, but this, not there, this was literally about 6 different little mini documents that I put together yesterday. And the biggest, pardon my French, but the biggest pain in the ass for the whole thing was copying over all of these things. Because when you copied it, it copied it 2 or 3 times sometimes. And I had to remove them and I had to recenter them and whatever. So it's just kind of a pain. All right. So I'm going to run through this, but I don't want to spend more than 10 minutes or so on it. So what is an ER diagram? This is the kind of thing that you're going to be creating. All right. Now you'll notice in here, from what we showed before, it doesn't show the relationships. All right. But what you're trying to define when you are showing those relationships is you're trying to define what kind of a relationship it is. It's one of those 3, remember. It's either a one-to-one, a one-to-many, or a many-to-many. All right. So this doesn't read real well. All right. But hopefully you can see it okay on the copies that I gave you. So I try to make this bigger. It starts to look, in my opinion, this was kind of hard to read. You may agree, you may not agree. I don't know. As it says, ER diagrams are related to a lot of other kinds of diagrams. I never even heard of a data structure diagram before this. I have not only heard of, but I've created DFDs, data flow diagrams. Now, back when I was your age, I may have shown you this before, and you probably don't care, but I'll show it to you anyway, and that is back when I was in my 20s and I was going to school, every time that we created a program, we had to buy one of these. Where does it show? No, not like that. What's your tool? No. Well, I'm trying to show it to you. Thought it was called something. It was with for a flowchart. Well, we had to write flowcharts, and we had to use these symbols. And literally for a while, we had paper that was like this big. You had to buy it from the bookstore. It was about double the size and double the width of like, it's like putting 4 pieces of typing paper together. And it had grid lines on it. And you had to draw this, and you had to show how everything was connected for every program you did. And it sounds like, boy, that sounds like a pain in the, and it was, but you really knew what it is because the instructor had to okay everything you did before you were allowed to even turn the machine on. All right? Not exactly the way that it is today. All right. So Peter Chen, as it says, back in the 70s, he wrote this paper, now what, like 45 years ago? And he's kind of the father of ER diagrams. All right. Again, I don't want to sit and read to you. They're used for a lot of things. In our case, they're going to be used for database design. All right. And the idea is they're, for lack of better words, a pre-tool. So you want to create those before you go in and you create the database. Sometimes by creating things like this, what happens is you're like, oh, I forgot about that. or geez, I didn't realize that these two things are actually connected to one another. All right. So the main things in there, we already talked about what an entity is. All right. Notice that entities can be categorized as strong or weak. All right. And it says a strong entity can be defined solely by its attributes and a weak entity cannot. For what we're doing, it doesn't matter. An entity is an entity. All right. Now, I've already talked to you about these. All right. You know what a primary key is. You know what a foreign key is. We talked about what a candidate key is. All right. We've also talked a little bit about relationships in here, and those are the symbols that you use for attributes. Notice it's not that big a thing, but typically you underline the one that's the primary key. All right. As it says here, attribute categories, they can be simple, composite, derived, so there's a bunch of them. Simple, as it says, means it's atomic, so it's in its smallest state. So in other words, if I had name here, name wouldn't be a simple attribute because you can divide name into first name and last name. First name and last name would be simple attributes. All right. Derived, so that name would kind of be a derived attribute. All right. Cardinality, this is another important thing. All right. And you look at these and you're like, oh man, look at those symbols. Well, you notice that when there's a many in there, it has these crow's feet. Here, here, and here. When there's a one, it has, typically at least, it has the railroad tracks, the railroad ties or whatever. This is the only one that's not 0 or 1. Now, almost always, again, it's going to be, you know, what sometimes people don't understand is, when I went over the traversy thing, rather, all right, comments and posts. Would you agree that posts would be kind of like the one side, and comments would be the many? In other words, I can have many comments for the same post. That makes sense. But the idea is when you talk about something being many, it means 0 or more. It doesn't necessarily mean 1 or more. Some of those posts had no comments, but it was still a one-to-many relationship. All right, so as it says up here, cardinality defines the numerical attributes between two entity sets. 1-to-1, 1-to-many, many-to-many. All right, so as it says, typically nouns are entities. Okay? Typically verbs will show relationships. Typically adjectives will show entities, as will or can attributes. All right. These are the symbols, but over the years, what has happened is different people have come up with different types of symbols. They're pretty similar, but there are differences. So this was the Chen notation here, and here's some examples of his notation. So you notice 1-to-1. So we're assuming one employee manages one team. So one employee cannot manage multiple teams. Here's a 1-to-many. Sometimes it's called M, sometimes it's called N. It doesn't really matter. But one customer can have 0 or more orders. One department can have 0 or more employees. But we're assuming that those 0 or more employees all report to one department head. All right, and many-to-many, we talked about this yesterday. Many students can take many classes. Many classes can be taken by many students. All right, this is the crow's foot style. So this is pretty similar, but not exactly what you saw before. This is the Bachman style. This one I had not seen before. The other ones I all had. The IDE fix style. The Barker style. And then there's examples. Like I said, it's not the goal here to see how long I can drone on talking about this stuff. So let me give you the next assignment. Let me see if I've got it up here. Oh, I guess I skipped a little, so we're almost done. Conceptual, logical, and physical models. It says ER models and data models are typically drawn up to 3 different levels of detail. All right, notice conceptual, as it says, is the highest level because it has the least detail, so it's the most general. All right, logical, as it says, it has more detail, and typically each logical model will become a physical model. All right, you'll start to break up one logical model into multiple physical models. Limitations of ER diagrams, yeah, they're set up to work with relational data. So they wouldn't really work with a NoSQL database like when we go into Mongo. Why? Because Mongo databases are unstructured in many ways. All right. And it says difficulty integrating with an existing database. And all they're saying is typically you'll make the ER diagram first. In fact, there are tools that you can buy that you can go and you can use an ER diagram, run it through, have an electronic copy of it, run it through a tool, and it'll create at least shells of a database for you. And finally, again, you sort of saw this on the other one, but how to draw a basic ER diagram. Now, on the homework, you're already going to know your purpose and your scope. You'll have to identify the entities. You'll have to identify the relationships. You'll have to identify the attributes. And you will have to identify the cardinality. All right? And then they give you some more tips. I'll let you read those on your own if you're interested. All right. So before I give this out, go grab one. Okay, that's fine. Grab one. All right. Who's got ones? Okay, who else has got a one? Okay, so you two will work together, and then you two will work together.
Okay.
You don't have to keep those, but you can keep those if you want them. All right. So let me pass these out. This is all pretty much taken from the PowerPoints that we looked at yesterday. There they are. All right, so let's take a look at this. I have this one open. Yes. There it is on the screen, and you've got copies of it as well. All right, so again, you all will already know the purpose of your database. All right, you don't have to write out the goal and the purpose. But as far as the information, it's not that you're going to go out and discover and collect it. It's that hopefully you'll know it, because it is going to be students and courses and stuff like that. So it should be stuff you already understand. You will then have to take the information and figure out your entities. Your entities are going to become your tables. All right. Then you'll, as it says, you'll have to associate all the bits of data. Those will be your attributes. All right. Then you will identify your primary keys and your foreign keys. You want every table must have a primary key. Typically, you're just going to call it ID. And typically, it's going to be an int. Okay. And then you want to identify all of the relationships, the cardinality, and when it says direction, which if it's a one-to-many, which is the one side, which is the many side. Some of them will be like that. You'll just get it. All right, probably most of them. If you come up with many-to-many relationships, you need one of those bridge tables where you need to put the primary key from the two tables into its own table. Make sure that there's a foreign key on the many side of every one-to-many relationship. All right, so as it says, using the information provided in class, create a MySQL database called school, following the requirements shown on the following pages. And you'll notice, I'm going to give you the rest of, if you may get much of it done today, because I'm going to give you now 1:45, so 2 hours to start on it today. If you say it's too noisy in here, if you want to go and work downstairs, I don't really have a problem with that. I'll probably come down and check on you. I don't want you to leave. all right? But unfortunately, with spatial issues here, as you know, we don't have a lot of space, all right? So let's take a look at what's in here. Again, I took these right off the PowerPoints. So break into groups of 2. We've already done that. Now, one of the things that I emailed you, just so you know, on that email that I sent you today, let me bring that back up. So one of the things that I emailed you where it says more resources, all right, it says attached are some resources. We already went through this one, how to draw an ER diagram. We already went through this one. What is an ER diagram? So we've gone through both of those. This one you have to unzip. It's in a folder called umlet.zip. All right. And since I've already got it unzipped, I'm going to go to my downloads, and you'll notice that I've got a thing that's called umlet. All right. Let me just, I'll re-unzip it. So there's umlet. I already went in and added some extra stuff to this. Now, what I'm about to show you, I don't know if you remember, but yesterday on one of Mr. Smith's slides, he said, go to this URL and look at this YouTube on here. It's 4.5 minutes long, and it has absolutely nothing to do with what you're doing. So I don't know where he got that from. I went and looked online for good YouTube videos on umlet. I couldn't find any. But what I want to show you is this. So after you unzip it, it's going to look like this. You double click here, and you double click in here, and you double click on umlet.exe. That starts it up. Now, when you look at it, it's like there's nothing in here that we want to do. And that's true. All right. In fact, I've got ERD. You probably have got a different one. And if you click up on top here, I don't know, what does yours say up there?
Yeah, no.
Okay. That right there.
Yeah.
If you go ahead and click on that and choose ERD. Guess you could choose the colored one if you wanted to, but I just chose ERD. So if you come out here and you literally, if you look on the screen, it's literally drag and drop. See that? That's literally all it is. You can go in and you can make things different colors, etc. There's, you know, I can go in here and I can create. I don't remember how to do this. I was playing with it before. Copy that, paste it. So there's an arrow. You can go and you can have this and then make it go like over, you know, etc. If you play with it a little bit, I think you'll figure out how to use it. All right. And what I showed you as far as running it, etc., I'm not sure if that's the best way to run it, but I played with it a little bit last night and that way worked. So that's why I showed you what I showed you. Does that make sense? All right, let's just finish going over this then. So you've been broken into groups of 2. The first thing you were to do is to develop an ERD using this. And it's funny because I watched a few videos. Some of them call it umlet, some call it umlet. But I think it's umlet because that was by the official people who put it together. So design a database to store information about your courses, including students, teachers, courses, assignments, and grades. Now, is each one of these going to be a table? That's for you to decide. Some of them you can look at in there, at least the top 3 probably will be tables, right? Do you want a separate table for assignments and grades? That's something you will decide. All right? So you have to do that. And then as it says, this is basically, it says, implement this in MySQL, because you can do it in Workbench also. I don't care if you do it in umlet. And if you try doing it and you go, I don't even understand how to do this, then go back into MySQL Workbench, because they've got a thing in here also that will allow you to create these. All right. I haven't looked at that, but I'm sure that if you Google it, you can find that out. So I don't care if you do it in one or the other, or try each one and see which one you're most comfortable with. Does that make sense? You don't have to do this twice, is what I'm saying. All right. Then I actually want you to create the database. So I don't care if you do it in PHP or if you do it in MySQL Workbench, either one. But create the create the database called school, create the tables with their schema, and add a few records into each one of them. Does that all make sense? All right. Then as it says, write queries that will answer the following questions. What is you can read those yourselves. All right. Add yourself and your current courses to the database using an insert. Test these in MySQL Workbench, or again, if you'd rather, then test them in PHP I don't care. All right. The one nice thing about using this is I can go and I can grab this, and then I can go out to something like Notepad++, and I can just paste it right in. It's a little harder to do that with PHP all right, but not much. All right, and then finally, says use the database you previously built and write queries to do this. So in other words, you're going to do these queries, and you're going to do these queries. Does that all make sense? So I'm going to give you the rest of the period to work on it today. Then tomorrow, what we are going to do first, and it's in one of the handouts I gave you, but if you don't have the handout, it's no big thing. We're going to download one of the built-in databases. I think it's called Scalia from MySQL. And then there's another homework where you're going to have to run some queries on that. That you can do by yourself, or if you want to do it with the person you're working with, that's fine as well. All right, questions? You understand what you're supposed to be doing? All right. So again, if you want to meet in here, fine. If you want to meet in another room, that's fine as well.